Alright, the first thing I'm going to do is I'm going to show you this circuit working. And it's going to be very noisy because the light that I have on the circuit has a switching supply. My computer is behind me. This camera is on. All these things that are on produce really loud static. Now, you should be able to hear CHU Canada through the noise. Now, do you hear that extra noise now? That one there is the camera. In other words, when you tune the voltage, okay, when you tune this, you're tuning all three diodes, okay? This circuit is a triple tuned front end for a radio, and it uses toroid coils. Now, I'm going to go through it, the whole thing, at the level for someone who has built with toroids before, okay? I can't help the beginners because there's so much you have to learn about winding toroids, and I'll give you some tips. But in other words, it will help if you have wound coils before for circuits and you know what to expect, all right? Okay, start off with, there's three, hopefully this is all focused. There's three diodes. They look like transistors, but they're varactor diodes. They're MVAM109, and they're 450 picofarads without any voltage on them. As you put more voltage on them, they go lower in capacitance, okay? And that's what this pot does. It varies the voltage through three 470,000 or 470K resistors. Now, the varactors themselves are coupled to the coil to a 0.1 microfarad capacitors. You don't put the variable capacitors, or the variacs, they got other names to them, varicap, you don't put them directly across the coil. You use a 0.1 microfarad capacitor. Now, each one of these coils has 35 turns of number 27 wire. Okay, 27 gauge wire. And they're wound exactly the same. The leads that come off are the same length. And the reason you do that is, as you're tuning these three together, you want them to track together. This isn't a bandpass filter. This filter is tuned to the frequency you want to get. Now, a bandpass filter, this same circuit, you wouldn't have variable caps or varactors, or you wouldn't have these varicaps in there. Okay, you would have tunable ones, and you would tune these two coils, two outer coils, to one frequency, and this one to a lower frequency, and that would allow frequencies within a certain range to go through from the antenna into the receiver. Okay, and the reason you build something like this is you want to eliminate noise. You only want that frequency you want to receive to go through from the antenna into the receiver. It's a filter. Okay, that's the first line of defense on a good radio, is the front end filter. Now, you take something like this. Everybody's, oh, the rage. No input filter at all. Garbage. Absolute, incredible garbage. No shielding, total garbage. Okay, I have two of them. I'm so disappointed in them. But anyway, I went back to this. Years ago, I built one of these in an Altoids can. And I want to tell you also that there's three identical tuned circuits, and they're coupled with 10 picofarad capacitors. Okay, the first one is coupled on the high end, on the top of the coil, to the next coil, 10 picofarad. Then from this one, 10 picofarad to the output. Now, if you want to come in with an antenna, just a high impedance antenna, a rod antenna, you come up to this point here. You come in at the top of the first coil. Now, each one of these has 35 turns, exactly same spacing between the turns on all three, and that's to get the tracking. Now, each one has 3 turns as an impedance. In other words, you can come in with an antenna and a ground. You have to have a ground if you come in through the 50, let's call it 50 ohm impedance. You come in, 50 ohm impedance, then the signal gets tuned, gets transferred, gets tuned again, gets transferred, gets tuned again, and it comes out on a low impedance 3 turns. Now, this one also has 3 turns. That's in there just for testing. Now, what I found was, And this is hilarious. Whenever I just hung a wire off the top of the coil over here, which would be the high impedance input, no ground involved, the circuit worked great. But then when I come in with an antenna on the low impedance side of the 3 turns, it didn't work at all. And I was like, it needed a ground. See, this is a ground lead going over to the light fixture. Okay, I can show you that. All right, let's tune this in again. I took the battery off. Let's tune it in again. Now I'm going to take the ground off. Nothing except noise. Okay, that's one of the things I was like, holy crap. All right. So in other words, if I put the antenna up here on the high impedance, a lot more noise, but it does work. And that was what's fooling me. I'm like, for the 3-foot wire, I get better signal than when I come in the low impedance. And you notice the low impedance is a lot quieter, okay? And it's because there's a ground and the circuit really resonates. Okay, let's try it now. I bumped the radio off a little bit. Alright, so it's fading out right now. But anyway, all three coils are wound the same. The leads off them are the same. Okay? I just showed you about the impedance. Now this circuit has no amplification on it at all. It's strictly a front end filter for a radio. If you decide to build a radio from scratch, and there's information on the internet, this would be the best front end filter. Now it's only good for from CHU Canada to a little above 9 megahertz. Now you're going to say, well, there's a lot of other frequencies. Yeah, well, you'd have to build another board for those frequencies and then have a switching mechanism. I realized that my listening habits at night are 80 meters and some shortwave down in there, broadcast station, shortwave broadcast station. So I realized what frequency range I'm in at night, what frequency range works the best at night, and when I build a radio, that's what I build it for, okay? And I can tell right away how good it's working. Now, in this case, when you listen to CHU Canada, it does fade in and out a little bit, But like I was telling you before I started, the light here that I'm using to light this board up to help it stay in focus, hopefully it stays in focus, has a switching supply on it. So you hear that buzzing noise and hissing. The camera being this close, that produces a noise on the radio through the circuit. And then my computer's behind me making all this work, and that puts a lot of noise. But you shut everything off in the house. This has no switching supply on it. It doesn't have an oscillator on it. And its only purpose is to allow just the frequency that you want to receive to come through. And that helps eliminate atmospheric noise because it makes the Q of the signal sharper. Okay, atmospheric noise is always going to be there. Man-made noise gets filtered out in a good filter. Okay, but I built this circuit once before and I wasn't really happy with it. And I built it again. And I made sure all 3 of these coils were wound the same. And I made sure that these varicaps, all 3 of them, were from the same batch. All right, and as I tuned it, you can tell it's right on there. You can get all 3 of these lined up so the signal will come through. But I wasn't getting any luck with the low impedance signal. And then last night I'm laying in bed and I'm saying, I remember when I used my R71A shortwave radio, putting a ground on it only helped a little on signals below 6 megacycles. And you'd say, well, how come it only helped a little? Well, that's because the R71A has a ground lead from the power supply and the chassis to radio that goes into the electrical plug. It's got a 3-prong plug. So if you add a ground on and off on the radio, you see very little difference in the amount of signal. Okay? And then there was a trick. If you had a long wire antenna, one of my friends says if you unscrew the outer connector and just leave the hot in on the antenna, you'll get even more signal. And that makes it electrically longer, the wire. Okay? Because you're removing the ground of the shielded wire that goes out to your antenna. And there was a couple trick things. You're like, now in my mind, I have all that figured out. But a transformer and that's what basically a toroid is. It's a tuned transformer. And if you're using the high impedance, it works fine, okay? But if you want to take a wire that's got both the ground and hot, you got to have a ground from that antenna into the circuit. A transformer winding needs 2 leads. It won't work with just one. It works slightly, okay? And that's what was driving me crazy. I kept thinking my 3 coils weren't exactly tuned on. So I said, someday I'm gonna make the circuit over again. I'm gonna really into making the coil. And then I did that, and it didn't change anything. So now you're saying, okay, and everybody sells these filters, and I'm getting like no signal through it. And it all turned out to be it needed a ground, okay? And as you go higher in frequency, the ground becomes less important. That's the other thing that throws you off, okay? And you're like, holy mackerel. But I just wanted to show you that. If any of you guys who work with toroid coils thought of doing a triple tune filter. Now, like I said, there's a guy that sells a kit to build the bandpass. So if you're thinking of building a direct conversion radio, you like to tune the front end of a direct conversion radio. All right. So instead of winding the coils yourself, you buy a front end kit, and I think he does make you wind the coils though. But if you go look at my video, I showed you how to wind coils. These are T50-2s, okay? And you have to buy these a bag of 25. The guy just won't sell you 3 of them. It's not worth his time. You know, people go, oh, they make you buy 25 of them. I only need 3. I see those messages all the time on the internet. Well, the shipping is worth more than those 3 toroids, okay? And that's the whole thing. If you're in the game, you got to play the game. There's certain rules to the game, okay? And I wanted to tell you the wire I use. I have old wall warts. You know, the power adapters you plug in. If you crack them open, you get a nice spool of like 27 to 30 gauge wire. And I won't say it'll be a lifetime supply. I've broken more than 3 of them open and used all the wire because I have a habit of winding a lot of coils. I will build something 2 and 3 times just to figure out what I'm doing wrong. And sometimes it's just as stupid as not adding the ground. Now, when you're on this workbench, you'd say, well, I got a long wire antenna running along the floor, but what do you use for ground? Well, I have a plug back there, and I have a banana jack in the ground lead of the socket, and I've had to expand the banana jack so it would fit tight, and I bring it over to here. Now I got my ground and antenna. What a difference. But that's because we're at 3.33 megahertz. Now, as you go up higher in frequency, ground isn't as important, but it is when you're transmitting, okay? But for receiver, it's not as much. I think that's it. I just wanted to show you the circuit and to tell you that, you know, you can get 3 tuned in a row. There is a kit, but it's a bandpass filter. But if you at my level or getting towards my level, you should be winding your own toroids and experimenting. And even these variactor diodes or varactors. There's 3. There's varactor. There's another name for them. I'm getting old and I can't remember, but they're MVAM 109, and these are the ones that are used in transistor radios for a few years. And you have to buy them on eBay. Other places don't sell them anymore because they're obsolete. And this replaces a mechanical capacitor that has 3 sections that are all the same, that tune together the same. Okay, I have one of those. I paid a lot of money for it just to build one of these circuits in something else. And I actually did a 2-section, and then the 3rd section is the oscillator. I think that's it. All right, that's it.